Are fine. Students, today we will discuss some MCQs of chapter haloalkane and haloarene in recent book. This is the unit 6 of class 12th chemistry. Okay. So students, let's see. Question number first. Our question number first is, which of the following is most reactive towards nucleophilic substitution reactions? Some options are given. Which one is most reactive towards the nucleophilic substitution reaction? Okay, this is the students. We know very well what is the order for nucleophilic substitution reaction. Here, benzylic, haloalkane or haloarene. Okay, this benzylic is haloarene. Okay, aromatic it is. So most reactive benzylic. After that, allylic halide, then tertiary halide, then secondary, then primary, then methyl, then vinyl. So this one is the order, you know very well. Then students, you will follow this order, and according to this order, you will give the answer. You will select the correct answer. Then, let's see. First one is the C6H5Cl. C6H5Cl, what is this? Chlorobenzene. This is the chlorobenzene. No, chlorobenzene is least beta. This is the aryl halides are the least. Why? Because here this carbon, the carbon at which this halogen is attached, this chlorine is attached, this is the sp2 hybridized carbon. This one is the sp2 hybridized carbon. Okay, and students, this chlorobenzene show resonance also. It show resonance also. Due to resonance stabilization and due to the sp2 hybridization of this carbon, which is making it more electronegative. Okay, these two are making less polar, this bond. This bond between carbon and halogen, carbon and chlorine. So student, from here this chlorine cannot be removed easily. This chlorine cannot be removed easily. Why it is? Because this carbon at which halogen is attached, it is sp2 hybridized carbon, and here S character is more. Due to more S character, this is more electronegative. So it is not easy to remove this halogen, this chlorine from here. That's why chlorine cannot be removed easily. Okay, so and it is resonance stabilized also. Due to this reason, this is the least reactive towards the nucleophilic substitution. It do not show nucleophilic substitution reaction in normal condition, only in drastic conditions at very high temperature and pressure it can show the reaction. Okay, so students, it cannot be the correct option. We cannot go with this one. Now this one, CH2 double bond CHCl. This one. If any functional group, here halogen we are having, is attached to the doubly bonded carbon, Here halogen is attached to this one carbon, and this one carbon is doubly bonded carbon. Then it is known as the vinyl. This is known as the vinyl. So this one is the vinylic chloride. Vinyl chloride it is. And you can see the order. Vinyl is also less reactive towards the nucleophilic substitution reaction. So we cannot go with this one also. Now, Cl, CH2, CH, double bond CH2.
Let's see. 2 double bond CH2. Let's see. 2 double bond CH2. 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 2 double
This one is Cl, CH2, CH, double bond CH2. Students, if halogen or any functional group, it attached to the carbon which is just next to the doubly bonded carbon, then it is known as the allylic. This one is known as the allylic position. So this is the allyl, this one is the allyl halide. Allyl halide. So it comes at second position after benzylic. It is most reactive towards nucleophilic substitution reaction. Then see next one. It is also vinylic because halogen is attached to the doubly bonded carbon. So we cannot go with this one also. Then students, here this one is the allyl halide, and this is the correct option for this question. This is the correct option. Okay, so allyl will be the most reactive towards the nucleophilic substitution reaction. And if you have benzylic also in option, then you will go with benzylic. What is benzylic? When benzene ring C6H4CH2, C6H5 CH2Cl. This one is the benzylic chloride. If you are having this one also in option, then you will go with this one. But it is not in our options, but allylic in our option. So we will go with this one. So here C is the correct option for this question. I hope this question is clear to you all. Okay. Then students, let's see the question number 2. In question number first, C will be the correct option. The most reactive nucleophile among the following is. Which one is the most reactive nucleophile? Nucleophile means nucleus loving. Nucleus loving. Nucleus loving means which is electron efficient species. Which one is the electron efficient species? Okay. So CH3 O negative, C6H5 O negative, CH3CHO. Okay. Then this. So students, here we can go with option first. We can go with option first. This one. Because here C6H5, it shows resonance, so it will attract electron towards itself, and which will decrease the density of electron on oxygen. Okay, so students, here we can go with option A. This CH3O negative is the most reactive nucleophile. Most reactive nucleophile. I hope this one is also clear to you. We will see the tendency which can lose. So, which have more electrons. That is the most reactive nucleophile. Okay. Then students, question number 3. The main difference between CX bond of a haloalkane and a haloarene is. What is haloalkane? Alkane, students, any R group we are having. If halogen is attached to this one, okay, any R group like methyl, ethyl, maybe. If halogen attached to this one, haloalkane and haloarene. Arene means benzene ring will be here, and any halogen will attach to this one like this. This is chlorobenzene. Main difference between CX bond X mean any halogen. Here I am having chlorine, but any halogen you can have, any. If you are having this X, X is halogen here, X is halogen. Maybe fluoro, maybe chloro, bromo, iodo. These may be. Okay. So students, what is the difference between bond of this carbon, this CX bond, and here also carbon. So what is the difference between these CX bonds in haloalkane and haloarene? Let's see the option. CX bond in haloalkane is shorter than haloarene. No, students. Students, you know very well. Haloarene, they show resonance. They show resonance. Resonance show करेंगे. And if they will show resonance, then like this. If I talk about chlorine, here chlorine has 7 valence electron. 1 electron consumed in bond formation with this carbon. So 6 are available here. Then students, delocalization can take place here. Delocalization can take place. During delocalization, what will happen? This chlorine, it will lose bond with this one and positive chlorine. This bond, electron of these bonds are shifting here, so negative. This means you can see double bond. This is the partial double bond character. Partial double bond character. And students, you know, if I triple bond, lowest, then double bond, and bond length will be maximum in carbon to carbon single bond. In carbon to carbon single bond. Okay. Then students, haloarenes are showing partial double bond character. So in this, in haloarene, this bond length between carbon and halogen, it will be shorter. It will be shorter. This bond length will be shorter as compared to the bond length of carbon and halogen in haloalkane. So students, it is opposite. Here CX bond in haloalkane will be longer as compared to the haloarene. So we cannot go with this option. We cannot go with this option. Okay. haloalkane में जो carbon halogen बॉन्ड होता है, हेलोअल्केन की बॉन्ड लेंथ हमारी ज्यादा होती है. ऐसा क्यों? क्योंकि वहां पर जो कार्बन टू कार्बन सिंगल बॉन्ड है, कार्बन टू कार्बन सिंगल बॉन्ड है, sp3 हाइब्रिडाइज्ड होती है. हाइब्रिडाइजेशन व्हाट विल बी sp3. ओके. एंड स्टूडेंट्स, हियर इलेक्ट्रोनेगेटिविटी कम होगी. इलेक्ट्रोनेगेटिविटी, इफ s कैरेक्टर इंक्रीजेज देन इलेक्ट्रोनेगेटिविटी increases. Okay. Then students, यहाँ पर इलेक्ट्रोनेगेटिविटी भी कम है, जिसकी वजह से ये बॉन्ड लेंथ क्या होगी? ज्यादा होगी. Okay. Then in haloalkane, the carbon attached to halogen in carbon and halogen bond is sp3 hybridized, while in haloarene it is sp2 hybridized. Yes students, if I talk about if I talk about haloalkane, so here halogen is attached to the single bonded carbon, singly bonded carbon. Then students, it is sp3 hybridized carbon. It is sp3. But in case of haloarene, the halogen attached to the carbon at which halogen is attached, this is the doubly bonded carbon. This one is the doubly bonded carbon. And if it is doubly bonded, then it is the sp2 hybridized carbon. This one is the sp2 hybridized carbon. So CX bond is sp3 hybridized in case of haloalkane, and in haloarene it is sp2 hybridized. So this one is the right option. We can go with this one option. Okay. Then students, CX bond in haloalkane acquire a double bond character. No, in haloarene it acquires a double bond character. In haloarene it have partial double bond character during resonance. Partial double bond character it shows in case of haloarene, not in haloalkane. So this is also not correct. Then haloalkane are less reactive than haloarene due to difficulty in CX cleavage. No, here cleavage of this bond is hard. It is not easy due to partial double bond character of this bond and due to resonance stabilization of phenyl cation. Okay, then students, here it is difficult to break this one, but easily we can dissociate this one. Okay, so it is also not correct. So here option B is the correct option. In haloalkane, carbon is sp3 hybridized at which halogen is attached, and in haloarene, carbon is sp2 hybridized at which halogen is attached. I hope this is clear to you. Then students, our next question is question number 4. Which is the correct IUPAC name for? Students, sorry for misprinting. Here compound is not given. So we will go with next question now. Our next question is, aryl halides are less reactive towards nucleophilic substitution reaction as compared to alkyl halide. It is saying this haloalkane, or we can say alkyl halide. Here halogen is chlorine, so I can say alkyl chloride. Okay. Now this one aryl halide. In halogen I am having chlorine, so I can say aryl chloride. So what is the question here? What is the question here? Aryl halide are less reactive. These aryl halides are less reactive. Students, these are the less reactive towards nucleophilic substitution reaction. Okay, nucleophilic substitution reaction. As compared to this one. Why? Already I explained here, students. In case of haloarene, due to resonance, it shows partially double bond character. Bond length will be shorter, and due to shorter bond length, it is difficult to cleave this bond. Okay, one reason is this one. Second one, here after this, it will give phenyl cation and it is unstable. Instability of the phenyl cation And students, here this carbon is sp2 hybridized carbon, which is more electronegative, so it will attract electron towards itself. Okay, that's why also. And it show resonance also. It show resonance also. And due to delocalization of pi electrons, they will repel also. So repulsion also taking place here. Then students, we will see the options. Our option first, formation of a less stable carbonium ion in aryl halide, resonance stabilization in aryl halide, presence of double bonds in alkyl halide. No, in alkyl halides not. Inductive effect, we can go, but not dominant factor it is. This one is also not dominant factor. So students, resonance stabilization, this one is the dominant factor. So we can go with this option because resonance stabilization is the main factor here. So we can go with this option because in case of aryl halide, resonance take place. And due to the resonance stabilization, it is less reactive towards the nucleophilic substitution reaction. Okay, I hope this concept is also clear to you all. Then question number 6. Para-dichlorobenzene has higher melting point than its ortho and meta isomer. Why? Students, para means 1,4 position. Para-dichlorobenzene means this is chlorobenzene. Para means at 4th position. At para position also one more chlorine here. This is the para-dichlorobenzene. Ortho 1,2 position. This is ortho. This is para. This one is ortho. And meta is 1,3. This one is the meta. What is the question here? Question is that this one is having highest melting point. Students, melting point, boiling point, they depend on stability. They are directly proportional to the stability. If any compound will be more stable, then its melting point will also be high. Its boiling point will also be high. Okay. Then you can go. Here, this one, para is more stable. Why it is more stable? Because it is showing symmetry. Due to the symmetry, it can fit in crystal lattice easily. Okay, it can fit with crystal lattice easily. One, may due to the symmetry. Second, students, here both chlorines are present at maximum distance, so possibility of further repulsion will be minimum. That's why we can also say it is more stable. Okay, and then ortho and meta will be less stable here. Then let's see the options. Let's see the option. Here, option A, meta-dichlorobenzene is more polar than ortho isomer. Not, because we want to compare para, so we cannot consider this one. Para isomer has a symmetrical crystalline structure. Yes, this one is the right option for this one. Okay, so because para has symmetry, it shows symmetry. Due to the symmetry, it can fit in crystal structure, in crystal lattice very comfortably, very easily, and in better way. Okay, so students, we will go with this option. Boiling point of orthoisomer, no, it is not right. Para, boiling point and melting point will be high. Okay, all of these are not all correct, so we will go with this option here. Option B is the correct option for this question. I hope this one question also clear to all. Then students, which sequence should isomeric dichlorobenzene be boiled in? Already I discussed in previous question. So what will be the order? Para, ortho, meta. This one. Para, ortho and meta. Next one is, which of the following substance has highest melting point? Has highest melting point. Students, boiling point or melting point? Directly proportional to they are directly proportional to the molecular mass. They are directly proportional to the molecular mass and inversely proportional to the branching. Inversely proportional to the branching. And they are also directly proportional to the surface area. Surface area. First of all, you will see the molecular mass. If molecular mass is same, then you can go with surface area. Okay. So here see the options. Option A, chloromethane. Chloromethane is CH3Cl. Tetrachloromethane CCl4, trichloromethane CHCl3, dichloromethane CH2Cl2. Here students, chlorine are maximum in which? In CCl4. Okay, so it have more molecular mass. Okay, so due to the highest maximum molecular mass, we can go with this option because it has maximum molecular mass. Okay, so van der Waals force of attraction will be greater. That's why boiling point is also high. So we can go with this option. Next one is, which of following statement about SN2 mechanism is correct? About SN2 mechanism. What are the main points of SN2 mechanism? First thing, SN2 mechanism take place in single step only. It take place in single step only. Backside attack will take place. Attack will take place from backside. Here second order kinetics will follow. Means rate of reaction will depend on concentration of both reactants. On both. Concentration of alkyl halide as well as on concentration of the nucleophile. Okay. Then students, let's show the inversion configuration. The product which we get, it will show the inversion configuration. Transition state will be formed as an intermediate. So these are the main points. Let's say the options. The transition state is stable. No. If transition state is stable, then how can we reach at our desirable product? Okay, so it is not. Because transition state is behaving like an intermediate, so it is unstable. Okay, so we cannot go with this one. The complete mechanism take place in single step. Yes, mechanism take place in single step. We can go with this one. Let's see the next option. The rate of reaction depend on concentration. Rate of reaction depend on concentration of both reactants. Yes. Rate of reaction also depend on concentration of both reactants. There is an inversion of configuration. This one is also right. Yes, but it is asking about incorrect statement. But it is asking about incorrect. So which one is incorrect here? This one. So students, this is the right option. This is the right option. Okay. You will read statement also carefully because he is asking about incorrect statement. All these three are the correct, but this one is incorrect. But for this question, this is the right option. Okay, I hope this is also clear to you. Then students, our next question is, which of the following is a primary halide? Primary halide. Isopropyl iodide. Isopropyl iodide. It will be secondary. It will be secondary. Okay, secondary already by name we can tell it is secondary. Tertiary, it will be tertiary. Neohexyl chloride, yes, we can go with this one. Here isopropyl, it is secondary. Secondary already given. This is also given. So neohexyl chloride. What is neohexyl chloride? 1, 2, 3, 4, 5, 6, 7. This one is the formula for neohexyl. 1, 2, 3, 4, 5, 6. Yes. This one is the neohexyl chloride. So students, here halogen is attached to which carbon? Halogen. This is halogen. This is attached to this one carbon. And this one carbon is attached with only other one carbon. Only with one other carbon. So this carbon is the primary carbon. This is primary and halogen is attached to this one. So this is the primary halide. This one is the primary halide. Okay. So D will be the right option for this question. So students, I hope all questions are clear to you. So that's all about you for today. Thank you. Have a nice day.